Welcome. In this video, we're going to determine if three vectors are coplanar, that is, if they are in the same plane or not, using cross products and dot products. So do these vectors A here, which is 1, 4, negative 7, and B, 1, 1, 3, and C, negative 0, negative 2, 2, are they on the same plane? Well, to figure this out, let's look at the parallelepiped, that is the volume of the parallelepiped, through these three vectors, or not through these three vectors, it includes one corner with these vectors in it. This triple scalar product here, that is the dot product of the first vector with the cross product of the latter two vectors, will provide us with that volume of the parallelepiped formed by these three vectors. And if that volume is anything but 0, then we know these vectors are not coplanar. Now, as we've already figured out, we can come up with this volume using one matrix. If you have not seen that video yet, I suggest you go back and rewatch that video to see how this can be computed using just one single matrix. And that matrix would be the vector A, which is 1, 4, negative 7, the vector B, 1, 1, 3, and the vector C, 0, negative 2, 2. So this becomes 1. Now cover up the two numbers below the 1 to get 1 times 2 is 2 minus negative 2 times 3, which is negative 6, so I'll get a positive 6, minus 4. Again, cover up the two numbers below, and we multiply by 2 minus 0. And then finally, cover up the numbers below the negative 7. And here we multiply 1 and negative 2, and then from that we subtract 0. So this becomes 8 minus 8 plus 14. So this is not equal to 0. So the volume of the parallelepiped formed by vectors A, B, and C is not 0. Hence, these three vectors are not coplanar. All right, keep calm and math on.